Okay, so the next question it asks, oh, I didn't have it ask that, but we're going to go ahead and ask that. What is the acceleration of this thing? So what is alpha? And so let's think. We have, if I have a net force net, we know that that is what? Mass times acceleration, right? So in terms of torques, let's see, if I have a net torque, what am I going to have? I'm going to have mass times acceleration, but we need to convert that in terms of something that's rotating. So when we have something rotating, our mass is going to be replaced with inertia, and our acceleration is in terms of alpha. So remember, this is just our rotational acceleration. So I can define alpha then in terms of inertia and the torque. We've already determined the torque. Now what about the inertia? Well, I have two things stuck together. So the nice thing about all things physics is this idea of superposition, that if I know one thing, if I add them all up, then I learn what the total thing is for that particular system. And that thing could be our electromagnetic waves from last quarter. We're going to do the same thing this quarter with waves, and now in terms of inertia. So I'm going to want the sum of my inertias to get my total inertia for the system. So for two cylinders, my inertia is defined in terms of 1/2 mr squared. So I'm going to have mr1 squared plus 1/2 mr2 squared. Mass 2, mass 1, mass 2, r squared. So for this one, I haven't given you a mass. I don't know. Yeah, we don't need to solve it or numerically. We can just set it up. So let's say that mass 2 equals, and mass 2, I'm going to call this outer one, equals twice mass 1. So I'll get that I is going to equal 1/2 mass 1 r1 squared. Well, we know what that is. R1, I'm giving this 0.3 meters is the radius. Yep. 3 squared. And then plus 1/2 m2. Well, m2 is twice mass 1. It's just going to let us combine some things. Times 0.5 squared. And in the end, let's see, what do we get? Let's simplify it. So 1/2 m1 0.3 squared plus m1 0.5 squared. Sweet. So I can do all sorts of things, or I can just put that in my calculator, and let's see what we get. And then for this, I get that the final answer, and I'm just using mass is in kilograms, so the units don't get confusing with mass 1 in meters. I get that for my inertia. Therefore, my alpha, my alpha is going to equal, well, torque divided by inertia. So my torque was this negative 6.7 meters. 0.7 Newton meters divided by 0.295 kilograms meter squared. Sweet. And we can simplify that further. That's going to go away. And then we'll see that, let's see, Newton is what? A Newton is mass times acceleration, so kilograms. Holy moly. Kilograms meters per second squared. So I look at that. What am I going to end up with? I will end up with my meters canceling out, my kilograms canceling out, and I will have per second squared, which makes sense because it's radians rather. So it's this unitless kind of thing that floats around out there. So there we have it. So the next thing that we will do is look at this in terms of just inertia and combining masses that'll get us to energy, which is very fun.